Hello everyone. Today we are going to start learning about environmental science, some topics related to NET UGC, environmental science portion. So today we are going to learn about social issues and the environment from unsustainable to sustainable development. Sustainable development is defined as a pattern of social economic development which optimizes the economic and social benefits available in the present without spoiling the likely potential for similar benefits in the future. A primary goal of sustainable development is to achieve a reasonable and equitably distributed level of economic well being that can be perpetuated continuously for many human generations. Long term sustainable development requires an understanding of the interaction between human activities and natural processes. So, displacement of materials by industrial and agricultural activities cause the most severe anthropogenic stress on the natural system. Hence, the understanding of human induced material flows and the comparison of this with the natural flows is essential to promote sustainable development. By 2050, our planet will need to support some 10 billion people compared to about 6 billion today. That raises huge challenges in food, clothing, and shelter for this rapidly growing population without depleting the world's resources and eroding the inheritance of future generations. The answer is sustainable development, a concept which seeks to balance economic and social progress with concern for the environment and the careful stewardship of natural resources. For sustainable development, society must meet the needs of the population and address social and economic inequality. But sustainable development also means managing resources effectively and maximizing the benefits we get from them so as not to overload the world's ecosystem. While most agree to the objective, how we achieve this is the subject of heated debate and calls for action by government, businesses, organizations, and ordinary people around the world. Sustainable development implies using renewable natural resources in a manner which does not eliminate or degrade them or observe otherwise diminish their usefulness for future generations. It further implies using one renewable exhaustible mineral sources in a manner which does not prevent the future generations from accessing it. The sustainable development also requires depleting non-renewable energy sources at a slow enough rate so as to ensure the high probability of an orderly society transition to renewable energy sources. Based on the above arguments, sustainable development has been alternatively defined in various manners. Some of them are as follows: development that meets the needs of the present without compromising the ability of future generations to meet their own needs. The World Commission on Environment and Development. Then, sustainable development ensure that the maximum rate of resource consumption and waste discharge for a selected environment the development portfolio would be sustained indefinitely in a defined planning region without progressively impairing its bioproductivity and ecological integrity. So, environmental conservation, therefore, contrary to general belief, accelerates rather than hinders economic development. Therefore, the development plans have to ensure sustainable and equitable use of resources for meeting the needs of the present and future generations without causing damage to environment. To prevent further damage to our life supporting system, to conserve and nurture the biological diversity, gene pool and other resources for long-term food security. And the primary objective of sustainable development is to reduce the absolute poverty of the world's poor, though providing lasting and secure livelihoods that minimizes resource depletion, environmental degradation, cultural disruption, and social instability. So, sustainable development is currently a catchword and, as such, is often used and abused. Therefore, before we examine an issue of sustainable development, it is necessary to examine the concept itself. Some parameters for defining the concept are given here, and a number of competing visions are offered here for a better understanding. At present, sustainable development means different things to different people. The most widely held definition is that of Brundtland Commission report of 1987, As stated earlier, we must meet the needs of the present without compromising the ability of future generations to meet their own needs. In other words, when people make decisions about how to use Earth's resources such as forests, water, minerals, ge- gems, wildlife, etc., they must take into account not only how much of the resources they are using, what processes they used to get those resources, and who has access to these resources. Are enough resources going to be left for future generations to use, and will the environment be left as we know it today? So, even though the term sustainable development is new, the basic concept is very old. The profound and complex problems covered by the term can be traced back to the earliest human civilizations, and the perennial tension between population growth and economic development on the other hand, and the use of natural resources and ecosystems on the other. There is strong evidence suggesting that sustainable development constituted a challenge to our earlier societies dating back to ancient Sumerian and Mediterranean civilizations. The term sustainable development, however, is a recent invention coming into common usage following the publication of the Brundtland Report 1987. Although even the term's origins may be traced back to before the 1972 United Nations Conference on the Human Environment. The concept of sustainable development has multiple meanings, and that each is equally legitimate. It is noteworthy that a universally accepted definition does not exist for many basic concepts used by society, even for those who are seen to concern our well being. That is why sustainable development, without a commonly accepted definition, appeals to virtually all groups who choose to participate in the environmental debate. Under such conditions, being pro sustainable development entails no risk or commitment to a specific set of goals or conditions, since none are agreed upon. Almost any group can find their own interest somewhere within the concept, and it is therefore hard to be against it in general. This allows the banner of sustainable development to be used by competing groups towards different or even contradictory ends. And the concept of sustainable development can be broken into two parts. One is the sustainability, which relates to the question of the carrying capacity of the earth while giving no attention to social issues, particularly those concerning equity, and social justice. Development is the second part and would appear to assume and even necessitate continual economic growth and ignore the question of ecological constraints or carrying capacity. When these two concepts are put together, a very different one emerge, and the result is much more than the sum of the parts. It is therefore a multidimensional concept, and it must be addressed at various levels simultaneously. So, sustainability can be divided into three types: social, ecological, and economic. The ecological definition is perhaps the clearest and most straightforward, measuring physical and biological process and the continued functioning of ecosystems. Economic definitions are sharply contested between those who emphasize the limits to growth and carrying capacity and those who see essentially no limits. Similar to global environmental change, sustainable development remains first and almost here that the limits to the globe sustainability for humans are more urgently social than they are physical. In other words, we will reach the social limits of sustainability before we reach the physical ones. Thus, our focus should be on society based solutions for managing the multiple aspects of global change rather than on technology based ones. Hence, it is important to emphasize the human aspect of sustainable development, institution, and political constraints. Any conclusion about the meaning of sustainable development remain dependent on considerations of context and spatial and time delimitations. At a global level, the following set of definitions serve well. In the narrowest sense, global sustainability means indefinite survival of the human species across all the regions of the world. And a broader sense of the meaning specifies that virtually all humans, once born, live to adulthood and that their lives are quality beyond mere biological survival. The broadest sense of global sustainability includes the persistence of all components of the biosphere, even those with no apparent benefit to humanity. Just as various groups hold different perspectives on the environment, each attaches its own meaning to sustainable development. Each of these views is given as proof for the necessity of a particular strategy or action. Depending upon which view of the environment is held and which meaning of sustainable development is advanced, opposing interpretations are rejected. Other views are not seen as simply misguided but are instead perceived to be blatantly wrong and threatening. In India and sustainable development, India has made substantial progress in most spheres of development over the past 50 years, particularly in the last 2 decades. During the last 2 decades, the Indian economy has been growing at about 6% per annum, making it one of the best performance economies in the world. Social indicators have also improved over the period. So, literacy and enrollments have risen while morbidity and mortality have declined. The gender gap has also declined and poverty rates have fallen steadily. However, it still has a large number of poor. The growth rate of population declined from 2.25% per annum in the 1970s to 1.69% in the late 1990s. Certainly, India is the largest contributor to world population growth, adding about 17 million people, and it probably increased. This book is a bit old, so I'm not that much up to date. I need you to search the current trend or the current statistics. Okay, so this might contain some statistical errors. Just ignore those portions and just focus on the theory. However, the benefits of this impressive growth have been substantially offset by environmental degradation. Even though India has a rich tradition of environmental conservation, large scale environmental degradation has resulted from population pressures, industrialization, and the indiscriminate use of forest areas for fuel, power generation, and irrigation purpose. The spread of input intensive green technology has given India a certain measure of good food security, but it has been at the cost of falling water tables, degrading soils, poor management of irrigation systems, and the harmful side effects of increasing pesticides and fertilizer use. Industrial growth and uncontrolled urbanization pollute water, air, and land. Similarly, rapid economic growth lead to changing lifestyles, such as increased use of automobiles and plastics, are also putting an immense stress on resource and the environment. All the circumstances raise the issue of how to achieve environmental sustainable economic development. In this context, it is fundamental that policymakers and the public understood how society and economy have changed and how they cause environmental degradation. And urban problems related to energy. A fast growing economy, India is targeting ambitious growth rates of 7 to 8% over the next 2 decades. So, economic growth coupled with the growing population necessities an increase in energy consumption. Alongside the imperative to reduce poverty by meeting the basic needs of the poor enters energy a crucial input for India's development process. The need of the hour, however, is to meet the energy needs of all segments of India's population in the most efficient and cost effective manner while ensuring long term sustainability. Then, urban energy crisis. Current patterns of energy use, especially based on fossil based fuels, raise serious concerns for three reasons: the finite natural resource of such energy, its detrimental effects on the global environment, the threat to long term sustainability. There is a legal and moral obligation to create an energy use pattern that ensures energy efficiently, protects environmental integrity, and maintains and enhances strength of our local economy. The present pattern of consumption of petroleum products in India is very important, which I won't be explaining. Then, three key issues that are likely to define the shape and future of energy in the cities are the following: sustainability, how much and at what rate is energy consumed, and its effect on long term sustainability, the quantity and quality of available alternative renewable forms of energy, and the effect of existing energy use on the global environment as a whole. Then, efficiency, the technology, planning, and management of energy systems that will facilitate efficient use of energy for human activity. And then equity, the appropriate financial mechanism for research, development, and use of finite and alternative energy forms, and their equitable distribution of all humankind. And some important issues on energy utilization and urban planning. Urban planning with concern for the efficient use of energy will create an effective urban environment. Urban planning with concern for the urban anatomy can create efficient systems that can support each other effectively, such as transportation network that alleviates traffic congestion. Urban planning with concern for the natural physical conditions can create an urban environment that would not be adversely affected by natural constraints, such as land surface below sea level and does not allow for proper drainage of water pools left by rainfall. An urban energy auditing system is an important first step in understanding energy consumption patterns and useful in evaluating the shift toward an integrated urban energy planning. So, the move toward reduction in use of fossil fuels has to go hand in hand with the following: exploring alternative energy resources, linking energy with global environmental issues, for example, climate change or global warming, then correlating environmental management efficiency with energy efficiency, changes in lifestyle, and increase in community involvement. Many of the global environmental problems that we are currently facing, such as climate change, biodiversity loss, desertification, etc., need at its core a campaign towards cleaner and greener energy that will stimulate action in other fronts in governance, education, and technologies. So, renewable energy. India recognized the importance of increasing use of renewable energy sources for achieving a sustainable energy base in the early 1970s. During the past quarter of a century, a significant thrust has been given to the development, trial, and induction of a variety of renewable energy technologies for use in different sectors. Renewable energy is seen as an effective option for ensuring access to modern energy services in our vast country in India. In addition, it also provides a degree of national energy security. In recent years, the rationale has been further increased by the environmental imperative. Local and regional environmental problems associated with the generation of conventional energy have provided a strong argument for enhancing the role of renewable energy within the broad energy development plans of the country. More recently, the Kyoto Protocol agreed at the Conference of Parties to the Framework Convention to Climate Change in December 1997 adds a global perspective to the environmental imperative. The importance of increasing use of renewable energy source is the transition to sustainable energy base has recognized in India in the early 1970s. During the past quarter century, a significant effort has gone into the development, trial, and introduction of a variety of renewable energy technologies for use in different sectors of the economy and sections of society in India. With a strong industrial base and successful commercialization of technologies in wind, solar, photovoltaics, solar thermal, small hydel, biogas, and improved biomass stores, India is in position today to offer state of the art technology to other developing countries and is poised to play a leading role in the global movement towards sustainable energy development. So, the importance of increasing use of renewable energy sources in the transition to a sustainable energy base was recognized in India in the early 1970s. During the past quarter, a significant effort has gone into the development, trial, and induction of a variety of renewable energy technologies for use in different sectors of the economy and sections of society in India. With a strong industrial base and successful commercialization of technologies in wind, solar, photovoltaics, solar thermal, small hydel, on other biogas, and improved biomass stores, India is in a position today to offer state of the art technology to other developing countries and is poised to play a leading role in the global movement towards sustainable energy development. The Ministry of Non-Conventional Energy Sources Government of India is involved in the implementation of these programs for development, demonstration, and utilization of various renewable energy based technologies such as the following: solar thermal, solar photovoltaics, then wind power generation and water pumping, then biomass combustion, cogeneration, small, mini, and micro hydropower, solar power, utilization of biomass, gasifiers, biogas, improved cook stove, then geothermal for heat applications, power generation, energy recovery from urban, municipal, and industrial wastes, and tidal power generation along with chemical sources of energy, fuel cells, alternative fuel for surface transportation, and hydrogen energy. And next topic, water conservation. Our ancient religious texts and epics have give a good insight into the water storage and conservation systems that prevailed in those days. Over the years, rising populations, growing industrialization, and expanding agriculture have pushed up the demand for water. Efforts have been made to collect water by building dams and reservoirs and digging wells. Some countries have also tried to recycle water. Water conservation has become the need of the day. The idea of groundwater recharging by harvesting rainwater is gaining importance in many states. And in the forests, water seeps gently into the ground as vegetation vegetation breaks the fall. This groundwater in turn feeds wells, lakes, and rivers. Protecting forests means protecting water catchments. In ancient India, people believed that forests were the mothers to rivers and worshipped the sources of these water bodies. Some ancient Indian methods of water conservation and harvesting. The Indus Valley civilization that flourished along the banks of the river Indus and other parts of western and northern India about 500 years ago had one of the most sophisticated urban water supply and sewage systems in the world. The fact that the people were well acquainted and with hygiene can be seen from the covered drains running beneath the sheets of rains at which Harappa and Mohenjo-daro. Another very good example is the well planned city of Dhola, Dholavira in Khadir-Bet, a low plateau in the Rann in Gujarat. One of the oldest water harvesting systems is found about 130 km from Pune along Nain Ghat and Western Ghats. And next topic, rainwater harvesting. In urban areas, the construction of houses, footpaths, and roads has left little exposed air, earth, exposed earth for water to soak in. In parts of the rural areas of India, flood water quickly flows to the rivers, which then dry up soon after the rains stop. If this water can be held back, it can seep into the ground and recharge the groundwater supply. This has become a very popular method of conserving water, especially in the urban areas. So, rainwater harvesting essentially means collecting rainwater on the roofs of buildings and storing it underground. Storing it underground for later use. Not only does this recharging arrest groundwater depletion, it also raises the declining water table and can help augment water supply. Rainwater harvesting and artificial recharging are becoming very important issues. It is essential to stop the decline in groundwater levels, arrest seawater ingress, prevent seawater from moving landward, and conserve surface water runoff during the rainy season. Town planners and civic authorities in many cities in India are introducing bylaws making rainwater harvesting compulsory in all new structures. No water or sewage connection would be given if a new building did not have provisions for rainwater harvesting. Such rules should also be implemented in all other cities to ensure a rise in the groundwater level. Realizing the importance of recharging groundwater, the CGWB, Central Groundwater Board, is taking steps to encourage it through rainwater harvesting in the capital and elsewhere. A number of government buildings have been asked to go in for water harvesting in Delhi and other cities of India. All we need for a water harvesting system is rain and a place to collect it. Typically, rain is collected on rooftops and other surfaces, and the water is carried down to where it can be used immediately or stored. We can direct warm water runoff from the surface to plants, trees, or laws, or even to the aquifer. The various methods of rainwater harvesting are classified below under two categories: traditional and modern methods. So, traditional rainwater harvesting, which is still prevalent in rural areas, was done in surface storage bodies like lakes, ponds, irrigation tanks, temple tanks, etc. In urban areas, due to shrinking of open spaces, rainwater will have to necessarily be harvested as groundwater, hence, harvesting in such places will depend very much on the nature of the soil. Then modern methods of rainwater harvesting. The modern methods of rainwater harvesting are categorized as artificial recharging, absorption pit method, absorption well method, well cum method, then recharge trench cum injection well, rainwater harvesting, percolation pit method, bore well and with settlement tank, open well method with filter bed sump, then percolation pit with bore method. All these methods are very important, and we are going to learn about the reducing water demand in agriculture topic. Simple techniques can be used to reduce the demand for water in irrigation. The underlying principle is that only part of the rainfall or irrigation water is taken up by plants and the rest percolates into the deep groundwater or is lost by evaporation from the surface. Therefore, by improving the efficiency of water use and by reducing its loss due to evaporation, we can reduce water demand. There are numerous methods to reduce such losses and to improve soil moisture. Some of the methods by which sustainable saving in water can be brought about in agriculture are listed below. First one, mulching. The application of organic or inorganic materials such as plant debris, compost slows down the surface runoff, improves the soil moisture, then reduces evaporation losses and improves soil fertility. Then soil covered by crops slows down runoff and minimizes evaporation losses. Hence, fields should not be left bare for long periods of time. Then, ploughing helps to remove the soil around. Move the soil around. As a consequence, it retains more water and thereby reduces evaporation. Then, shelter belts of trees and bushes along the edge of agricultural fields slow down the wind speed and reduce evaporation and erosion. Then, planting of trees, grass, and bushes break the force of rain and help rainwater penetrate the soil. Fog and dew contain sustainable amounts of water that can be used directly by adapted plant species. So, artificial surface such as netting, surface traps, or polyethylene sheets can be exposed to fog and dew. The resulting water can be used for crops. So, contour farming is adapted in hilly areas and in lowland areas for paddy fields. Farmers recognize the efficiency of contour based systems for conserving soil and water. Then, salt resistant varieties of crops have also been developed recently because they grow in saline areas. Overall agricultural productivity is increased without making additional demands on freshwater sources. This it is a good water conservation strategy. And transfer of water from surplus areas to deficit areas by interlinking water systems through canals, etc. So, desalination technologies such as distillation, electrodialysis, and reverse osmosis are available. Use of efficient watering systems such as drip irrigation and sprinklers will reduce the water consumption by plants. Then every drop counts. It's a case study, short case study. Life in the Mahabubnagar district of Andhra Pradesh, South India is tough. It is a district that relies on agriculture, particularly the cultivation of paddy fields, but years of drought is taking its toll. As the ground dries up, so do the agricultural yields and also the jobs. Dams are being constructed in the state, but the water is being diverted into the more affluent coastal areas, leaving the people of Mahabubnagar fighting to make a living. Many adults are forced to move to cities such as Hyderabad or Bombay in search of job, at least until the drought eases. Children are usually left behind in the country with their grandparents to look after cattle, a trend which is given an impact on social attendance and hierarchy. And once the villagers start channeling wastewater back into the ground too, it is hoped the dried up wells will also start yielding water again, meaning the school will have two sources of safe water nearby. And water aid are tackling this problem by helping communities harvest rainwater and by channeling wastewater back into the ground to recharge the water tables. And with the help of this, they almost recovered from that problem. Water aid reads are developed. Thank you.